Um, Hi everyone, my name is Anish. Um, Today I am going to show you a demo of my project Sandstore, which is a learning first distributed file storage system written in Go. I built Sandstore because although I loved reading about distributed systems, I realized the best way to really understand them was to build them myself. But I couldn't find a good open source project that made it easy to experiment with storage, consensus, and replication. So I decided to create one myself. My vision with Sandstore is simple, to make distributed storage modular and pluggable, so that anyone can learn by experimenting. I chose storage because storage is the foundation of so many distributed systems, from databases to cloud platforms. If we make the core components modular, then you can mix and match, swap implementations, and see how things behave. That's actually why Sandstore is named the way it is. It's supposed to be a sandbox for distributed file systems. Here's a high level design overview. So I built a few core components in Sandstore, like the file service, the metadata service, the cluster service, and things like that. Now each of these is exposed as an interface. So for example, if we look at the communicator, I have built gRPC and HTTP implementations. But because it's an interface, you could swap in your own custom protocol, let's say a protocol built on top of TCP, and still leverage all the other parts of the system. So this modularity is what makes Sandstore a great playground for learning distributed systems. Since MCP servers are quickly becoming the standard to connect AI tools with real world systems, I wanted to explore how I could use AI to make it easier to learn and work with distributed storage. So I built an MCP server as well for Sandstore. It exposes the file operations directly to an AI agent. So things like storing, retrieving, and deleting files. And then it also has access to the logs that the system generates. So it can use these logs to generate a step by step explanation of what just happened. This means, so for example, you don't have to dive straight into the code to understand the Raft implementation or my Raft implementation, but rather you can interact with the system through natural language, run an operation, and actually have the AI walk you through exactly what happened under the hood. So I'll just give a quick demo for about that. So I'm in the Sandstore repository. You can clone this. I'll be providing the GitHub link in the description of this video. Uh, I'll just start a Raft cluster with three nodes, and then I will run the make MCP command to like actually make the MCP server. Now I have configured QCLI as my AI agent of choice. You can use the MCP server with whatever AI agent supports it. So I'll just start a QCLI interface. Now if I do a slash tools command, you can see that the Sandstore MCP exposes certain commands like delete file, store file, read file, and stuff like that. So let's just do something like this. Store a test file in and store with the name test1.txt and contents this in and store MCP. So I can also tell it to look at the logs and explain to me what happened. Uh, so once I enter this command, it will tell me if I want to trust this particular tool, which I will. And after it stores the file successfully, it looks at the logs which have been generated inside Sandstore, and then after looking at the logs, it is giving me an explanation about what exactly happened when this file was stored in the current Raft cluster. Now I've given an example of Raft, but you can do this with uh, like any of your own implementations to try and debug what is happening behind the hood. The other thing I'm going to experiment with doing is giving QCLI or any other AI agent through the MCP the ability to randomly kill servers and start servers. I think this will help in reasoning about what happens exactly in consensus protocols when network partitions or node failures happen. Um, so thank you. This was the demo for my project Sandstore. Uh, if you like the project, please look into contributing to the project. I will have the issues GitHub page linked in the description of this video as well. Thank you.